Welcome again to another mathematics tutorial, and today we are going to solve quadratic equations using graphs. In our previous videos we used different methods to solve quadratic equations. We use factorizing, we use the quadratic formula, we use completing the square. Today we are going to solve quadratic equations using graphs. Okay, so here we have a quadratic equation. We know it is quadratic because it has the x squared value. Okay, now if we're going to solve it using graphs, from our last video we looked at a graph that has both the x and y axis. Now according to this, now you don't see the y in there, right? Now if you're going to solve it, right, we say that this expression is equal to y, right? Y is equal to this. Okay, so now we can solve it. Now before we can solve it, we need to find the vertex. The vertex is the lowest point on the graph that's expressed by the x value. So if we have a graph, all right, and we have a curve on the graph after we solve it, okay, it's the lowest point here, okay, and we find the x value for that point. All right, it could be whatever the x is. It could be 1, it could be we try to find what that x value is. Okay, that's known as a vertex. Now the formula for vertex is x is equal to minus b divided by 2a. All right, a is this value here. Sorry, okay, all right, okay, yeah, a is this value, all right, and b is this value here. Okay, so the coefficient, this 2 is the coefficient of x squared, right, and that is where the a is here, and the minus b, right, is the coefficient of this x, which is 4. So to solve it, right, it will be minus 4 because there's a negative there, so it's 2 negatives, divided by 2, right, 2 multiplied by 2. Okay, so a negative is a plus, that's 4. 2 by 2 is 4. So this value of x as the vertex is 1. In here we use an example that it could be 1, but it's the lowest point on a graph expressed as an x value. Okay. Okay. So now we know that x1 at the vertex, but we don't yet know what the corresponding y value is. So what we do is that we find for values of x and y, find values for x and y. Okay, we know that x is 1, so we put it in the middle, right? Put that one in the middle here, all right, and this becomes 2. We try to value for 3. X is equal to 1, 2, or 3. This would be 0. This would be minus 1. So we want to find the values for y if x is equal to minus 1, 0, 1, 2, and 3. Okay, so we try to find the first one, x is 1, try to find a value of that. So if x is 1, we have to say if x, right, is equal to 1, then we just substitute into this formula here. So that means it's 2 to the power of 1 squared minus 4, 1 plus 1. Okay, and that works out to be negative 1. Okay, when you work it out, right? So y is negative 1. Right? We want to find if x is 2. Right? If x is 2, then we substitute that in. That's 2 squared minus 4 squared plus 1. Okay, and I've worked it out. It's 1 when we work it out. All right. If x is 3, right? Okay. If x is 3, then that's a 7. When you work it out, it becomes 7. Okay. So a good way of looking at it, from the vertex here, we looked at on the right, we see the x is 1. So this same as saying that if x is 0, y is 1. Right? This one, if x is 3, y is 7. If x is minus 1, right, this is the same as the 7. Okay? You can work it out, right, in your own time, right? It works that way. So if you want to plot it on a graph, okay. So it's important to note that when the x is 0 and the y is 1, this 1 is the y-intercept. Okay, it's where the curve cuts the y-axis. Looking at this formula, we see the positive 1, right? So we know that this 1 is the y-intercept. Okay, so if x is 0, right, y is 1, that's right here. Okay, that's the y-intercept. That's the first point. Okay, x is 1 and y is minus 1. X is 1, y is minus 1 is here. X is 2, y is 1. X is 2, y is 1 there. X is 3, y is 7. And we have the last one, minus x, minus 1, for x is minus 1, and y is 7. Okay, so we have some points here, and we just draw a line through them to connect the points. Okay, so your graph will be more accurate because you'll be using graph paper, but I'm just using freehand on a board here. So that is how we solve quadratic equations using graphs. Okay, so here we have another quadratic expression. Okay, x squared plus 2x minus 2. Okay, and we say y is equal to this because we want to solve it using the graphs with y and x axis. Okay, we find the vertex again. Vertex and the vertex is x is equal to minus b divided by 2a. Okay, so the minus b is the plus 2. That's the coefficient of this x. And that will be the minus 2. Okay, right? And divided by the 2, and this x squared, it's known to have a 1, so 1 value. So that's like 2 multiplied by 1. Okay, so that's minus 2 divided by 2 gives you minus 1. So we know the vertex is x is equal to minus 1. Now we know x is minus 1 here. So the lowest point is going to have to be at the minus 1 anywhere along where x is minus 1. So it's along anywhere there, right? That is what we know so far. So if we know that x is equal to minus 1 at the vertex, then we try to find for y by using possible values for x. Okay. Okay. So let's put the minus 1 there, right, in the middle. Okay, because we know that's the vertex which is in the middle, right? It corresponds to the line of symmetry. So we know that the x minus 1 is a line, and that line is the axis of symmetry. So we put this one here, right here in the middle here. Okay, and we try to find y if x is equal to minus 1. Okay, so if x is equal to minus 1, then it works out to be minus 1 squared, alright, plus 2, minus 1, okay, minus 2. Okay, we substituted minus 1 into this equation here where the x is. Okay, and we worked that one out, and it works out to be minus 3. Okay, I've already worked it out, but you can also work it out as well. If x is equal to 0, alright, then that's 0 squared plus 2 multiplied by 0 minus 2. That is minus 2, right? Because 0 squared is nothing, 2 multiplied by 0 is nothing, that leaves minus 2. Okay, if x is equal to, okay, right, 1, 2 here, these are the values there. If x is equal to 1, okay, that will be 1 squared plus 2 multiplied by 1 minus 2. Okay, and that's worked out to 1. Okay, so we know now that this is minus 3, this is minus 2, and this is 1. Okay, and if x is equal to 2, that's 2 squared plus 2 minus 2. That works out to be 6. Right? Now we know that these values already, so we can also know what these values are. Okay? So we know we're trying to find for minus 2, minus 3, x minus 4. Right? So if x is equal to 0, right, and this is the line of symmetry, then we know that this value here will be similar to this value, it's minus 2. this value here will be similar to this one, which is 1. This value of 6 will be similar to here, right? Because we looked at the axis of symmetry. What's equal on this side is equal to the other side, because it's symmetrical. Okay, but you can also work it out as well. You know, if x is equal to -2, -3, or -4, you will get these similar values there. Okay, so now we just right, we have these values now, and if we can plot it, we can plot the first one where the axis of symmetry is, right? X is -1, this is -1, and y is -3, so it's right about here, okay, as the vertex, right, where the axis of symmetry will be, okay. And we go for this one, x is 0, y is -2, which is right here, right, x is 1, y is 1, so got 1 here, it's 1, right over there, x is 2, y is 6, x is 2, y is 6, okay. And then we find the points for the others, -2, -2, -2, I will say, which is about here, -3, 1, -3 on the x, right, 1 for the y, -4, 6, -4, 6. Okay, so now we got the points. So now we're going to draw a line to the points. Okay, so there you go. And then the axis of symmetry. Right, divides the graph in 2 equal halves. Okay, so that is how we solve this quadratic using graphs. Okay, so here we have a quadratic expression that's slightly different from the others we did before. Okay, we have a negative value here. Now, if there's a negative value, right, the graph will be different. Okay, the graph is going to look a bit different. Before we were looking at graphs that looks like a U. For negative expressions in quadratics, the graph will look more like an N. Alright, so before we were looking at graphs looking like this, but now the graph will look like that. Okay, because it's a negative. But we will find values for x and y, and then we will see how the graph looks like. Okay, so we know this expression is equal to y if we want to solve it using graphs. So y is equal to that. And we've tried to find values, possible values for x and y. Okay, we know that the y-intercept is 6, so it's somewhere here. So we can begin by putting a point there, because we know that somewhere the graph line is going to cut the y-axis, which is known as the y-intercept. So we can, because we know of the y-intercept, and we can see, we can put the x here. We could put the 6 here, right? The intercept is there. We can put the 6 right in the middle. Okay, and we know that the x is 0. So we know one point just by looking at the quadratic expression. The coordinates for both the x and the y, we already know that this is the y-intercept, which is y is equal to 6, and we know that the value of the x is 0. So we already know that one. So, but that's all we know so far. Okay, so what we want to find out, okay, x could be 2 and 4. We can skip, we can say 2 and 4, right? This one will be minus 2, minus 4. Okay, and we just solve it by substituting the x value into here, and then we can get what the value of the y is. Okay, right? So now if x is equal to, say, 2, okay, that is equal to minus 0.5, 2 squared multiplied by 2 squared plus 6, right? That's equal to minus 2 plus 6 is equal to 4. Okay, so we know that this is 4. Okay, if x is equal to 4 minus 0.5, right, 4 squared plus 6, that is negative 8 plus 6 is equal to negative 2. That's a negative 2. Alright, and we know these values is 4 here, minus 2. Right, you can work it out in your own time, but it works out well. So we know that point of where the y-intercept is. We know that already. So we plot the others. So 2 and 4. So 2 and 4, and 4 and minus 2. Okay, 4 and minus 2 is about there. Okay, and we plot the others. Y is 4, and x is negative 2. Right, so y is 4. Okay, y is 4, and x is negative 2 there. Okay, and x is minus 4, and y is minus 2. Okay, which is about here. So if we draw the line intersecting the points, okay, we see the curve, right? It's been different from the curve before. Before it was like a U shape. Now it's like an N shape, right? It's quite different because we are dealing with a negative value, is a negative coefficient to the x squared. That is why we have the shape. We have the shape of the graph looking like that, looking like an N. Okay, so that's the end of today's session, solving quadratics using graphs. Thank you for viewing. Goodbye.